Hey guys, how are you? Today we are going to solve this hard limit. At the beginning, I recommend that you pause the video and give it a try. I will give you a small hint to solve this hard limit. You can think about the Riemann sum and the integral, so this problem will be easy in that case. So now I will solve it. So solution. I can see that this limit is in the form of a sum, so I will turn it into the sum of n tends to infinity sum of. I will introduce a new variable called k right there. So k will be, at the beginning it will be 0, and at the end it will be equal to n. And the summand, we can see that it will be 1 over 2n plus k. Now we have the limit of sum. So we are approaching to the Riemann sum, but we still have to do some changes in this summand. So I will multiply the numerator and the denominator by 2n. So it will be limit n tends to infinity of the sum k equal to 0 to n, and I will multiply 2n in the numerator, so it will be 2n over 2n plus k, and in the denominator 2n. I did that so we can approach the Riemann sum. So to get the Riemann sum, we have to find out the delta x, the small change in the x, and I will call it 1 over 2n. So in that case, we know that delta x of the Riemann sum is equal to p minus a over n. So we have to change this to the form of 1 over 2, it will be 1 over 2 over n. So we can see that b is equal to half, and half minus 0, so a is equal to 0. Now we also have 2n over 2n plus k, so that will be f of xi. But we can see that xi is equal to a plus k multiplied by delta x, so it will be 0 plus k multiplied by 1 over 2n, so it will be equal to k over 2n. So f of xi is equal to f of k over 2n. Let's change the color. F of kn is equal to the remaining part, which is 2n over 2n plus k. So it will be 2n over 2n plus k. So now we need to find out the f of x, the function. So we have to divide the numerator and the denominator by 2n, so it will be 1 over 1 plus k over 2n. So we can find out that f of x is equal to 1 over 1 plus x. So this will be an easy integral to evaluate. So the limit of n tends to infinity of the sum k equal to 0 to n of the summand, which is 1 over 2n plus k, it will be actually the integral from a, which is 0, to b, which is half, and the function we found out that it is 1 over 1 plus x dx. Now this is an easy integral to evaluate, so it will be ln of absolute value of 1 plus x from 0 to half. So we can substitute right now, so it will be ln absolute value of 1 plus half minus ln 1, so it will be ln 3 over 2, and ln of 1 is 0, so we found out that the limit is equal to ln 3 over 2, but the actual value was to find out what is a plus b. So we can see that a is equal to 3 and b is equal to 2. So the required question was what is the value of a plus b, so it is 3 plus 2, which is 5. So that was our limit for today. Thank you for watching. I hope that you enjoyed this video, and see you in the next time.